We're talking about solving quadratic functions by completing the square, and we have to get to a situation where we can use the square root property. In order to use the square root property, the side containing the quadratic expression has to be a perfect square. So in this case, our quadratic expression is on the left, and right now it is not a perfect square. Another issue that we have is the coefficient on the quadratic must be 1 in order to complete the square. So right now we have the lead coefficient here, which is -2. So we need to change that to 1. The first thing that we should do is we should get to the form x squared plus bx. And in order to do that, what we have to do is we have to add 48 to both sides. So we can add 48, and we can set this side equal to 0 and add 48, because we're trying to find where the quadratic function crosses the x-axis. So then we get -2x squared minus 20x equals 48. I left that space there because there's going to be some value that we are going to have to add here, that we're going to have to add to both sides in order to keep the equation balanced. So the next issue we have is our lead coefficient is not 1. So in order to make this 1, what we're going to have to do on this left side over here is we're going to have to divide by -2. And we don't have to do it on both sides because we're going to maintain that -2 right there. And so the -2 is going to stay there. And then we're going to get x squared. And -20x divided by -2 is going to be positive 10x. And then we're still going to have some value inside that parentheses there that we're going to have to add. And then that's still going to be equal to 48 plus that extra value. So what would make this the perfect square? We have to use that formula again where c is equal to b divided by 2 squared. So when we're calculating, we say c is equal to b divided by 2 and that quantity squared. So in this case, our b value is 10. So c is equal to 10 divided by 2 squared. 10 divided by 2 is 5, so that's equal to 5 squared. So c is equal to 25. So c is equal to 25. That's the value that we're going to add to this side over here. Now, there's a -2 over on this side. So really, we put plus 25 here, but really we're adding a -2 times 25. So that's what we're going to add on this side as well, -2 times 25, because we want to keep the equation balanced. That 25 is inside the parentheses with the distribution there. So this gives us a perfect square inside the parentheses. So we have -2 times, now we can have x in x times x is x squared. And then that value that gets squared is actually what we can add here. So we get 5 and 5, and they have to add to 10. So we get plus 10 and plus 10. And that is going to be equal to -2 times 25 is 50, or -50. 48 minus 50, so that's equal to -2. Now we can rewrite this, and so we have -2 times x plus 5 quantity squared, because x plus 5 times x plus 5 is x plus 5 squared, and that is equal to -2. And now we can start solving this by itself. So the first thing is we can divide by -2. Divide by -2, and we get x plus 5 squared is equal to 1. Then we can take the square root of both sides, and the square root of both sides we get x plus 5 is equal to plus or minus 1. And then at this point, we have to account for both the plus and the minus. So we subtract 5, and we get x is equal to -1 minus 5, and x is equal to -1, or excuse me, plus 1 minus 5. Then we can solve those two. So we get x is equal to -6, and x is equal to -4. And so those will be our two zeros for this one. And we can check those by graphing. So we get the point -6, 0 and -4, 0. And that is the solution for the zeros for that particular quadratic function.